Hi everyone, my name is Zuhair, and our today's topic is going to be super interesting because it's going to be all open source project, and we are going to develop interview preparation board for data science students and managers. And behind the scene, we will be using Llama 2 7 billion model, and it would be a quantized version of it, and we will be running it on our local CPU machine, and we are also going to leverage the capabilities of LangChain. So thanks to both the communities, LangChain and Hugging Face, because guys, they are doing a lot as the open source community. And if you guys still have not subscribed my channel, then subscribe it first. And with that, let's get it started. So guys, to create the chatbots by using PDFs, we need a couple of things to be set up at first. And the foremost thing is to set up an LLM. So since this is project is open source, we will be using the open source LLM. And in open source LLMs, we have the option to use like Llama models from Meta, like Llama 2, or it can be Falcon. But in this project, we will be using Llama 2 7 billion model, and it would be the 8-bit quantized version of it. Because in our local system we just have 16 GB of RAM, and we cannot run a Llama to 7 billion without being quantized. So the second thing is we will be needing some model to create the embeddings of the documents. So for that we will be using sentence transformer from Hugging Face. And the third thing that we need is to store those vector embeddings inside some vector database. So previously I have made a tutorial on a Pinecone vector database, but since we are using the open source vector databases, so we have the options to use like ChromaDB, Faz, or Quadrant. But for this tutorial, we will be using Faz from Meta. Yeah. So these three things we required to set up our pipeline, and for running the Llama 2 7 billion 8-bit quantized version, we need to calculate the memory, that how much memory it will take on our CPU machine. So if we say that like every parameter of the model will take 1 byte, like 8 bits, and then like one parameter like 8 bits or 1 byte, then we have total 7 billion parameters. They will take uh, 7 billion bytes in total. Since 1 billion byte is equal to 1 GB, so 7 billion bytes will take 7 GB of memory. Since we have total 16 GB of memory, so we can run it on our local CPU and make the inference to the model. So let's see how we can download this model and use it on our local machine. So we will be going to the block, uh, and we will be using Llama 2 7 billion chat GGML versions of them. So they have given us a couple of versions like to use, and we can see which one we can use out of them. So we have like a 2-bit quantized model, 3-bit, 4-bit, 5-bit, 6-bit, and 8-bit models. And 2-bit requires 2.87 GB model, but we need a good like 8-bit quantized model. So for good performance, so we will be downloading this model Q8, and it is about 7.16 GB. So yeah, so we can download this model by clicking on this button. And since I have already downloaded this model, it is about 6.7 GB. So we will not be downloading it again. So let's walk through the code and see how to set up the pipeline to use this Llama 2 7 billion quantized model. So I have made a folder in which I have placed our data, and our data consists of just one PDF file related to deep learning with Python, and it's a long document on deep learning with Python by Zois, and it is about, I think, 386 pages long. So we will be creating the embeddings of this book behind the chatbot, our chatbot. And yeah, so I have also placed the downloaded Llama 2 7 billion model here, .bin file, and I have set up a .py file in which we will write the code. So let's start with the coding. Uh, we need a couple of things to import. First, we will import OS, and then we will be needing a couple of things from the langchain library, like the vector store. We will be using the faz, so we will be importing that. And other than that, we will be using the embeddings from Hugging Face. And let's see. So the next thing is we will be using a recursive character text splitter to split our text, because we cannot give a very large PDF to our LLM. So we will be needing some kind of a text splitter. So for that, we will be using the text splitter from LangChain. And we will be building our bot with conversational retrieval chain from the LangChain, and it will work in the conversational manner. So let's import that as well. Since we are using the PDF documents to work on, so we will be needing a PyPDF loader from the LangChain. And yeah, so we will also be using the C transformers as a LLM from the LangChain. I will tell you for what purpose it will be used. So C transformers is a library uh, that develops the Python binding, and here you can see that to use the GGML versions of any model .bin file, we will be needing C transformers, and LangChain provides us the facility to import C transformers library. It is written in C++, and yeah, so we can set up the LLM by using this library. So that's why I have imported this library. So other than that, we will be importing a Chainlit library. So if you want to develop the front end for your chatbots, currently we have a couple of open source libraries to use. Uh, I have often used the Streamlit, but in this tutorial we will be using the Chainlit since it is very good for building the chatbots front end. So we can use that as well. And we will be also be using the memory because our bot is conversational, so it is very important to store previous conversations somewhere. So we will be using like conversational buffer memory. So if you don't know what is this sort of a memory, it is like just a buffer which holds the previous a certain number of utterances from the user and their responses. So we will be needing these libraries in our tutorial. So let's start to create the class for our bot, and we can say that it is PDF chatbot chatbot. So we will be giving the name like this, and we will be initializing some parameters in our constructor, like the path to our data, our folder name is data. Yeah. So next thing we will be using is the path to our vector database where our embeddings will be stored. So we can say like database phase path start start join. We will be storing the embeddings in this folder. So we have declared our constructor. Let's create the functions for our actual pipeline. So first we will be creating the vector database. So let's write the function for that. So we will be needing some to a loader to load our documents. We will be using the directory loader class from langchain, and it takes the data path. Then we can say that the files of which sort of extensions will be used for loading, and we will be using the PDF files, so we can say that, and the loader class will be used PyPDF loader. Yeah, so we have initialized the loader, and now we will create the documents. Our document is very long. We have to use recursive character text splitter to make the chunks of our document. So yeah, so it takes the chunk size, and we will be setting it to 400 tokens, and the chunk overlap to 50 tokens. So we have initialized our text splitter. So next thing is to use this text splitter to split our documents. So for that we have the function like split documents, and yeah. So the next thing is to initialize a model for the embedding since we are using the Hugging Face sentence transformer model. So let's initialize that. So the model that will be used is Almini LM and the full name is Sentence Transformers, like all mini LM L6 V2, and our model keyword arguments will be uh, we will be setting like device to CPU since we want this model to run our CPU machine. So this is our embedding model being initialized, and next thing we will be creating the embeddings of our model by using this embedding model. So for that we will be using phase class from langchain, and we will be passing like our previous chunks of text and the embeddings, created embeddings model, and it will be our vector database, and this database needs to be saved locally. So we will save it and we'll import it next time when we will be using it. So we can say the to the path where we what we have initialized earlier. So db fast path. So this is the function that will load our PDF documents and then we'll create the embeddings. Uh, and the next thing is we will be initializing the LLM that will be used to retrieve the answer against the query. Like we are using the Llama 2 7 billion, so we will be initializing that model and with the function load LLM. So we will be using C transformers library, and here we will be initializing our model. So this is our model name, and model type is llama, and we have to set up the parameter like max new tokens. So for now we will set it to 2000, and temperature we can set it to 0.5. So we have initialized our Llama 2 7 billion model, and the next thing is to use the conversational chain by using this LLM. So let's create a function for that. So we can copy this line. So we need to load our database here in this function by using dot load local function. So the next thing is to initialize conversational buffer memory. It will store the chat history and will decide the answer of the next question based on this previous chat history. So that's why we are using this memory. And the next thing is to initialize our conversational retrieval chain by using all these previously initialized elements. So let's do that. It will take the LLM. So we have already set up a function for that self dot load LLM, and we will be using that here. And yeah. So other than that, we will be using the retriever as db.retriever as retriever function. Search keyword arguments. We can set it to 3. So the next thing is since we want to see the mid working of our board, so we can set the verbose to true, and also we need to pass on our memory already initialized. Yeah, so we have initialized our conversational retrieval chain, and so we have all the things set up. So let's return this chain as well. So we have created the complete class. So it's time to call all these functions by creating the object of this class PDF chatbot. So yeah, so we are creating a function out of this class to initialize the chain. So let's create the object of this class with the name like bot. And now first we will call our first function like the create vector db to create the embeddings of our PDF document. The next thing is to initialize the conversational chain. So we will be calling the conversational chain function of bot, and yeah. So we will be returning now this conversational chain out of this function, and yeah. So we have all set up. We have used all the functions of our created class. So now we can create the chat history list in which we will save all of our previous done conversations. And yeah, so let's call the above initialized chain function here. So our chain has been created. So we can use this chain to make the inferences from our LLM on our PDF document. But since we want some sort of a front end interface where we can make the queries, so we will be using the Streamlit. And so to use a Streamlit, we will be creating two new functions. And yeah, so let's do that for as well. And but we need to install some libraries for that. So let's install the Chainlit as well. So Chainlit has been installed, and other than Chainlit, we also need some other libraries as well. So I will be needing the sentence transformer. So it will take a while to install this library. So bear with me. So the next thing to install is FAS CPU. We also will be needing to install uh, PyPDF to load the PDF documents. We also need to install C transformers Python embedding. So that's all the libraries we have installed. So let's see how to create the front end for the chainlet. So we need to create a function, async function with the name like which will work on the start of the bot when this function when the bot will be start these sort of commands will be run by the bot automatically. And yeah, so we will be showing some message on start of the bot like using cl dot message, and our content will be like starting bot. Next thing is to send the message on front end using message.send. Now we will change the content of our message after showing the welcome or starting the board message. So we will say like welcome to data science interview bot, uh, interview prep bot, and can say ask me the question. So next thing is to update our previous message. So we can say message dot update. And yeah, so this is the functionality that will be that will be executed when our bot will be started. And to use this functionality, we have to declare a wrapper around this function, and the wrapper name is on chat start. And also we will be needing a session to set up cl dot user session dot set, and we will be equalizing this to our already initialized chain. So the next function is to that will be called when a user will send the message, and yeah, after the start of the bot. So the wrapper for that will be used as on message wrapper. So let's write the function for that as well. So we will get the user session that already being created on the start of the bot with the key like chain. So we will be using async callback handler from this langchain. False. Then we will use answer previous tokens equal to final answer. So this is just a code has been copied from the Chainlit website, so I can place the code here. So we have written two functions for the front end. One is will be called when our chatbot will be started, and the other will be called when we will get the message from the user side. So let's run this code and see how our bot works. So data has been converting into the batches and stored in the inside the vector database. About 72 batches have been are being created. So our bot has been started, and the starting message is like, "Welcome to Data Science Interview Prep Bot. Ask me your question." So let's ask a question related to deep learning. So we will say what is overfitting and how to overcome it. So usually it takes about half to 1 minute to get the answer from Llama to 7 billion. Yeah, so we will wait for it. So behind the scene, the working is just like this way. It is starting some LLM stuff document chain and then entering into the LLM chain where the default prompt has been utilized, and these are the pieces of the documents being retrieved against our query, and we have set it to, I think, three. Number of three pieces from the documents will be retrieved against our query, and then this is our question, like what is overfitting and how to overcome it. So I think the answer has been given by our bot. So it says like overfitting occurs when a bot learns pattern found in training data rather than generalizing those patterns. So you see that it has given us the right answer, and the techniques used to mitigate overfitting include dropout, weight decay, L2 regularization, and early stopping. So let's ask the follow-up question like what is early stopping? So you can see that we made the inference at 147 and we got our response at 148. So you can see that it took about 1 minute to answer our question. Sometimes it gives earlier than that. Yeah. So behind the scene, what we are getting, we are getting the history from our previous made inferences, and yeah. So here the question that we asked was like, what is early stopping, and it has been rephrased by using the already set it prompt by the langchain, and it has been rephrased to what is early stopping in the context of machine learning. So this chain rephrases your questions, and in the context of the previous question being asked from the bot. So let's see the answer. So here you can see how much steps it is taking to answer our question. So it took one step here. So here you can see the chain. It first went into the conversation retrieval chain, then inside the stuff document chain, and then we get our answer in 2 steps. So yeah, so the answer is like early stopping is a technique used to prevent overfitting machine learning, meeting a target metric during training, such as the validation accuracy or loss. So it is also the right answer. So we can also ask more questions like what is regularization in deep learning. Yeah, so we will also get the right answer for this question as well. So this was the data science interview prep bot you can create by using a Llama 2 7 billion model, and it can run on your local CPU machine. So if your local machine has less than 16 GB RAM, then You can use the lower quantized model like 4-bit quantized version, but for my machine, like for 16 GB RAM, I use the 8-bit quantized model. Yeah, so that's all. If you guys have any questions, you guys can comment below. I will be happy to answer your questions. And till next video, see you guys. Take care. Bye bye.